In this particular question, the limit as x goes to 1 of the cube root of x minus 1 over the square root of x minus 1 is challenging because it requires us to rationalize the numerator and rationalize the denominator, but we have to use different techniques. The numerator is an example of a difference of cubes rationalizing, and the denominator is an example of a difference of squares rationalizing. Remembering that the difference of cubes rationalizing requires us to think along these lines. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. A minus b will be thought of as the cube root of x minus 1. We're therefore going to let a be the cube root of x and b equal 1. A squared is x to the 2/3. A squared is x to the 2/3. AB is x to the 1/3 times 1, and b squared is 1. So we're going to introduce a factor of x to the 2/3 plus x to the 1/3 plus 1 to the numerator in order to rationalize it. There we go. But when we introduce a factor to the numerator, you have to introduce it to the denominator. Similarly, we have to rationalize the denominator, so we introduce a factor of square root of x plus 1. And when we introduce that factor to the denominator, we have to introduce it to the numerator as well. If you like to read that explanation, it's right here. And coming back to our question, we're then able to see that expanding out these first two brackets leaves us with x minus 1. In the denominator, expanding out the first two brackets leaves us with x minus 1. We therefore have this factor remaining in the numerator and this factor remaining in the denominator after we cross out our common factors of x minus 1. We can then substitute the value of 1 directly in for x, and we're left with an ultimate answer of 2/3.